This lesson is 2.2c, writing the equation of a line given two ordered pairs. So we have written the equation of a line given a point and a slope. Today what they're not giving us is the slope. So you'll see in number 3 they give us two ordered pairs that it passes through. It passes through -2, -3, and it passes through 3, 2. What we can do then is we can actually find the slope of this line by taking the two ordered pairs they give us. So if you remember, we could label this x1, y1, x2, y2. And to find the slope of a line, we would do change in y over change in x, and that can go either way. So most of us are used to doing y2 minus y1, so that's the one I'll try. I would take 2 minus a -3, so I'm again looking at this 2, y2 minus y1, and then over x2 minus x1, so 3 minus a -2. When I look at my boom booms here, right, I end up with 5 over 5, so I get a slope of 1. So now I found the slope. That's really the only new piece from the other equations that we've done. We now can write the equation of the line in all three forms because we have a point and we have the slope. So to do that, the first form we start with is point-slope form. One thing you might be wondering is which point you should pick, because we have the slope, but which of these ordered pairs should you pick to write your equation in point-slope form? The answer is it doesn't matter. They both work. So I'm going to do it both ways to show you how they both work. You don't have to do it both ways though. You only have to do it one way. So the first one would be y minus -3, so I'm going to say plus 3, equals my slope, which I just found to be 1, right? So 1 times, and then I would have x minus x1, which is a -2, so x plus 2. There's one answer for point-slope form. Now, had I used the other ordered pair right here, I would have gotten a different answer. So it would be y minus 2, right here 2, equals the same slope, 1, times x minus 3. Either of these answers work. Neither one is better than the other. It does not matter at all which one you pick for point-slope form. So this is my answer for point-slope form. So now, to move this to slope-intercept form, I can use either one, so whichever one you chose to use. When I distribute a 1 to something, does that change anything? It doesn't, right? So really, I just have y plus 3 equals x plus 2. And to move it to slope-intercept form, I'm going to subtract 3 from both sides. So y equals x minus 1. Here's my answer for slope-intercept form. Now, just in case you're curious, would I have gotten the same answer if I had used this green one, this green equation right here? I should, right, because I told you they were the same value. So again, distributing a 1 doesn't do anything. So I'd have y minus 2 equals x minus 3. When I add 2 to both sides, look at that. Y equals x minus 1. Same answer. So there's your proof that you can choose either ordered pair, you're going to get the same answer. On a test, I will have, in my answer key, I have both the purple and green line listed for point slope, and then the rest of the problems have the same answer, so I don't have to change it based on which point you pick. And then the last step would be to move this to standard form. So we have y equals x minus 1, that was our answer, right? To move it to standard form, I need to put the x on the other side. So I would minus 1x from both sides. So I have -x plus y equals -1. Now, I look at that and I see that I'm in standard form. I have an x, a y, an equal sign, and a number. Am I breaking any rules? So first rule, greatest common factor is 1. Oh, I'm good. I can't divide all those numbers by the same number and change it at all. Second rule, leading coefficient can't be negative. Here's my problem, right? I have a -1 right here. And so to fix that, if you remember, we'd multiply by -1. So I then would have positive x minus y equals positive 1. And then the last rule is no fractions or decimals, which I don't have. So here is my answer for standard form. So again, if you have any questions on that, you can run through that part again. Take a look at all those different forms you put it in, but it doesn't matter which. Once you find the slope, you can disregard one of those ordered pairs. It's fine. fine to let it go after that. The second one here, number 4, you're going to find the slope first again. So we're going to have x1 and y1 and x2, y2. And when I find this slope, I'll do it the same way I did the last one. So I'll take y2 minus y1 over x2 minus x1. So again, I've got the plus plus here. So I end up with my slope is negative 11 over 7. Not the prettiest slope we've ever dealt with, right? But common. I mean, we don't need to have integers as slope. They often are fractions. So for tomorrow, I want you to use this kind of messy slope and run through point slope, slope intercept, and standard form. And then this is the problem that we'll finish in class tomorrow together. The last type that we're going to do then is this one here. Passes through 2, 1 and negative 3, 1. This is one of our special problems, and you'll notice in a minute why that is, hopefully. But let's start and do the slope, just like we did every other problem. As I do the slope for this problem, oops, that should be a 2, sorry. I take y2 minus y1 over x2 minus x1. So as I subtract here, I notice in my numerator, what do I have? A 0. And 0 divided by a number is 0. So my slope is 0. Anytime you have a slope of 0, you have a horizontal line. That is your line that you're given. Now, if I'm not sure about that and I don't know that, maybe that didn't come to me right away, I can go ahead and start plugging this into point slope form. So it doesn't matter, I'm just going to pick this ordered pair, 2, 1. So I would have y minus 1 equals 0 times x minus 2. So this is what I'd have for point slope form, except look what happens here. When I'm distributing a 0 to both parts, 0 times anything is what? 0. So I actually have y minus 1 equals 0. That's my point slope form. And if I want to move to slope intercept form, I'd add 1 to both sides, and I get y equals 1. This is the equation for a horizontal line. Y equals a number, and you will use that over and over and over and over again. So this would be my answer for actually both slope intercept and standard form. That's my answer for both. Now, how could I have known I was going to get that as an answer? Look at your original problem. Look at the y values. They are the same. Anytime that happens, it has to be a horizontal line. Think of this in a graph. I'm just going to sketch one here. But if I have the point 2, 1 and negative 3, 1, so 2, 1 is right here, negative 3, 1 is right here. How can I connect those 2 points to be in the same line? The only way I can connect them is to draw a line through them, right? So it has to be a horizontal line. If my y values are the same, the only thing that would work is a horizontal line. And if you look at it, just happened at 1, right? So y equals 1, which was the y values I was given for that. Now, what else you'll see with this is what if my x values are the same? Let's say they gave me the ordered pairs 3, 1 and 3, negative 7. X values are the same, they're both 3. So then instead of it being a horizontal line, it's a vertical line. So my equation for this would be x equals 3. And you'll run into both types. If you recognize from the first looking at the problem that the y's are the same or the x's are the same and you know the answer, you don't have to show me any work. That is just you knowing what that means, and you write the answer down and you're good to go. If you don't recognize it, you're okay in a horizontal line because you'll get a slope of 0. And if you get a slope of 0 and go, oh, that's right, that's horizontal, go ahead and write your answers. What happens when you have a vertical line is your slope for a vertical line is actually undefined. You would end up, when you found this slope, having 0 on the bottom. And that can't divide by 0, right? Unless you're Chuck Norris. So because of that, you're going to have an undefined slope, and you'll have your vertical line of x equals 3. And you run into those every once in a while. So if you have any questions on those when you run into them, let me know.